All right, so today we're going to be working with arc length and area of sectors, so things related to circles, spheres, all of that stuff. So the first formula we have here is how to get the arc length of a sector. A sector is just the word we use for a part of a circle. And the arc length formula is really connected to the circumference of a circle. So if we look at this formula, 2 pi r, that is just the circumference of a circle. And then we have to multiply that by whatever portion of the circle we have. So theta over 360, that is just going to get us the portion of circle in our sector. So we just, this formula is in the formula packet, but you can also, if you know the area of a circle, you can just multiply that by whatever percent of the circle we have. And we'll see an example in just a minute. The other formula we have here is the area of a sector. So similarly, the area formula is really closely connected to the area of a circle formula. So this pi r squared, you've known that since geometry at least, and that is our area of a circle. And then, like last time for sectors, we just have to multiply that by the portion of circle in sector. And we've got radius, we've got the angle, and those will be the key pieces of information that we need. All right, so for this example here, we've got the sector of circle AOB has radius 4 centimeters and central angle of 75. So if we are finding the arc length of AB, we first would just think, okay, what's the circumference of the whole circle? What portion of the circle do we have? So that will be, what letter are we going to use? We'll use L, that makes sense. So L, it's good to do kind of like curly L's if you're using L, just so you don't get it confused with 1. We have 75 over 360 of our circle parts with the sector that we're working with. And then the circumference of the whole circle would be 2 pi r, so 2 pi times 4. And then we just need to throw that entire thing into our calculator. I'm going to check that my mode is in degree. I am. It should be, as long as you don't reset your calculator, or if it dies, you might need to recheck. But let's see, if we got 75 over 365 times 2, we always want to use the pi button, which is, if we hit second and then pi, let me check a physical calculator to make sure it's in the same spot. Yes, it is. It's in the same button as the exponent, only you have to hit second first. And then r is 4. So we've got 5.16 when we're rounding to 3 sig figs. So 5.16 centimeters, since we are given units on this one. All right. So we've got now a new problem here. So determine the area of the segment enclosed by chord AB. So a chord, that's just a name for a line whose ends are on a circle point, or whose ends are on the edge of a circle, but it's not necessarily going through the center like the diameter would. So we've got a chord here, and determine the area of the segment enclosed. So we're only looking after this part here. But we can use what we know about how we find the area of triangles and what we just saw in our formula of finding the equation of a sector. And we'll just have to subtract. So kind of our overall plan here is, first we're going to get the area of the whole sector, and then we're going to subtract the area of a triangle. So to start, to get the area of the whole sector, so area of sector, we've got 75 3/60ths of our circle, so that will be area. I'm going to do a little subscript of sector, just so I remember. So area of sector is 75 over 360 times the area of the whole circle, which would be pi times 4 squared. So let's see what we get for that. And I'll use numworks this time just so we can make sure that we know how to find pi over there also. So if we are trying to find, 75 over 360 times pi. Pi is on, it has its own button just right there. That's nice. Pi times 4 squared. And we get 10.5 when we're rounding to 3 sig figs. For this one, we can put over here, I'm just going to put the whole decimal just with some dots because I want to remember that I want to use the exact value when I end up doing my subtraction in a few minutes, because otherwise if we round early, our final answer will be a little off. So we've got our area of the sector here. Now we need the area of triangle. And we'll get that next. So generally, when we first learn area of a triangle, we use that 1/2 base times height. But since in this triangle we don't have the base or the height, we have a base, we could consider for the base, but we don't have the height of that triangle, and it'd be kind of a lot of work to get there. Instead, we're going to use our new area of the triangle formula that we got in our last set of notes. So area of our triangle in general, that's going to be 1/2 AB sine C, where A and B are sides and C is the angle between them. We might think, oh wait, but if we look here, we only have one side in an angle. We actually do have this side too, because we know since it is also a radius, because it goes from the center to the side of our circle, it also will be 4 centimeters. So 1/2 AB sine C, when I work that out, that will be 1/2 4 times 4 sine of 75. So 1/2 and then 4 times 4 sine of 75, and that will be 7.73 if we're rounding, but we don't want to round yet because we are working with a measurement that's still in the middle of our problem. So now that I have that, I can just do the area of the sector minus the area of the triangle. A nice thing about clearly labeling what your calculations are, it allows us to write what we're doing without having to write out our full expanded decimals that are unrounded. So we're going to go up and grab our values from before and subtract them. And then what we end up with is 2.74. And from there, we're good to round, we're good to keep it at that because we're at the end of our problem. And we have units here. This circle is measured in centimeters, so this will be 2.74 centimeters squared. And that is our answer there. So that is some examples dealing with arc length and sector area, and in this case, another triangle area practice too. So, moving forward here, next we're going to work a little bit with spheres. So there's also a lot of similarities between the volume of a sphere and the area of a circle, since those shapes are really connected. We're really used to seeing pi r squared, and we do need to remember here that it's cubed. And luckily this is in our formula packet, so we don't need to memorize that, but we just need to fight autopilot when we're writing stuff down and make sure we write pi r cubed when we're working with a sphere. So r is the radius, and that's the only measurement we need of a sphere in order to get the volume. So that's radius. Similarly, for surface area, we use the radius to find that, and kind of cool. So the area of a circle is pi r squared. If that circle turned into a three-dimensional sphere, we would need 4 circle areas to cover the sphere, and it does that exactly. So when we are here finding the volume and surface area of a sphere, we've got, let's see, volume equals, where are we? We've got 4/3 pi r, and our r here is 9 squared. All right, not sure if you all caught that. I just went on and did my calculations like this and realized, wait, I did exactly what I told you all not to do. I put squared, I got carried away. I'm so used to pi r squared that I did not adjust for the fact that we're doing volume, and so we're working 4/3 pi r cubed. Very easy mistake to make there. So we've got 4/3, or here I'll use parentheses, 4/3 pi times r cubed, 9 to the 3rd power. All right, there we go. So our volume here is equal to, if we're rounding to 3 sig figs, it'll just be 3,050. It is completely fine if you also were to write out 3,054. That would be good too. You are able to be more specific in problems where it doesn't specifically say how much you would need to round to. You can give more as long as you round correctly. It would not be correct if you wrote 3,000. If you wrote 3,053, that would not be correct, because that isn't how you'd correctly round to the nearest digit. So make sure you're either rounding to 3 sig figs or more precise, but rounding correctly. The only exception, if it specifically asks for either rounding to the nearest number or rounding to 3 sig figs or rounding to whatever, you do have to do that. You can't be more specific in cases like that. All right, so we got volume. Surface area is 4 times pi r squared, so 4 times pi times 9 squared. So that will be 4 pi 9 squared equals, oh, okay, I used this squared button and the exponent button. Let's try that again. 4 pi times 9 to the 2nd power, or squared, one or the other. There we go. So we've got 1,020 if we're rounding to 3 sig figs, and I got to get units on both of these. Surface area is a 2-dimensional measurement. Area is 2-dimensional measurement, so centimeters squared. And then our answer from above is a cubic measurement, since volume is a 3D measure. So we got that one there. Okay, last part here is finding the surface area and volume of a hemisphere with radius 9 centimeters. So hemisphere, that is a half sphere. And This one here, especially since we do so many questions in context, we have to think carefully. Volume of a hemisphere will be easy. It'll just be what we got from above divided by 2. So I can just take that and divide it by 2. I'm allowed to use my rounded version since that was the end of a problem part before. So I could do 30/50 divided by 2. 30/50 divided by 2 to get 1,525 centimeters cubed, or it would have been fine if you went back up and grabbed your exact measurement and divided by 2. That would be fine too. Both of those, when rounded to 3 sig figs, would get you the same thing anyway. That's not always true, but we can use our rounded version at the end of a problem. I'll just draw a little note. We got that from there. Surface area is a little more complicated since, yes, we do need to take half of the curved part of the hemisphere, but there's also, if we think about a hemisphere, there's the curved part, but then there's also a base. So we would want to make sure we count the base of the hemisphere as well. So the surface area is going to be a combination of things. It's going to be what we got from above divided by 2, and then we're going to add that together with the base, which is just going to be a circle, and it'll be a circle with radius 9. So that would look like this. So we need to add that to the area of the circle, so that will just be pi times r, which is 9 squared. We're not going to divide the circle in half because it is a full circle that's a part of our surface area. So when we calculate that, 1,020 divided by 2 plus pi times 9 squared equals 764. And again, we're working with units. Surface area is centimeters squared. All right, so that is all for today on this one. We will gather up in class and do some more practice with circles.